Hey everyone, my name is Joseph Werle, Werle if you're in Germany. I'm here to talk about decentralizing identity on the web, mostly about self-sovereign identity and decentralized identifiers. Super happy to be here and excited. So a little about me before we get started. First, I'm using a Mac. I like to hang out online, so you can find me on sites like GitHub and Twitter. I work at a startup called Little Star with an amazing group of talented people. We built a media platform to help immersive content creators make their content ubiquitous, accessible across a bunch of devices, like many popular VR headsets, television, smart TVs, even helping distribute AR content for folks like the WWE. Those are actual people that were captured in Microsoft's holographic studio, and we help distribute that for them. I also help contribute to a new open source project called Aura that was born out of the company. Aura is actually built on some really cool tech that you guys all know, the DAT protocol, Ethereum blockchain, and decentralized identifiers. Aura is an ambitious project that tries to empower content creators by removing third parties, reducing hosting costs, and rewarding consumers. We're really trying to help content creators maximize the value of their work. So we built a proof of concept application to show you that we could do it. And we call it the Aura File Manager. We really wanted to do a quick demo, but as most of you know, the internet here is non-existent. Users of the application can publish a license to their content on the Ethereum blockchain, set a price in an ERC20 token, and share it directly with their audience leveraging the DAT network, effectively removing middlemen. The idea was to give control back to content creators. Control is powerful and often taken for granted. While we were building Aura, we realized how important that is. When you remove a middleman between individuals, you give control back to peers. So what is control? Well, by definition, the power to influence or direct people's behavior or the course of events. I highlighted power here to emphasize what this really is about. A middleman or an intermediary is an entity that exerts control of the parties it's positioned between. This pretty much demonstrates what that is. So what power does the middleman actually have? Authority. Authority over the interaction between individuals as middlemen intermediate between us. Arbitration over disputes, conflicts, claims. It's asymmetrical access because middlemen are well positioned to hold all of the information while we remain thin. They can become a single source of truth, which is kind of dangerous if you don't trust that truth. Ultimately controlling our identity and the attributes of it. This is a problem because often intermediaries vanish from the internet or just leak our data, or worse, they sell it. Well, what is identity actually? By definition, it says the fact of being who or what a person or thing is. But identity extends beyond that definition to more complex relationships and connections with other people, places, and things. Identity is not static. Identity for us, building distributed and decentralized applications, is a digital representation of an entity. It evolves. That can be people, computers, servers, networks, places, and often just crap because it's the internet. Computers need to work with identity. They operate in a world of chaos, and identifying the entities in which they interact with, abstract, or are concerned with has real-world implications. I'd like to take you through a few phases of the evolution of identity on the internet. In the early days of the internet, we had walled gardens, siloed identities, GeoCities, free webs. A lot of these websites you created accounts. Some of them required email addresses. Long before that, maybe not. And your entire world was encapsulated there. We then moved into, this is actually a little bit more. There are single hierarchical authorities, centralized or a hierarchy of centralized control. As the gardens grow, it became more centralized. Centralization definitely introduced more points of failure. Looks just like that again, more middlemen. Yeah, some examples if you're familiar with these old websites. We eventually moved into shared gardens, lowered the walls a bit, and entered into a federated identity place. This is where we kind of are today. Single sign-on, shared identities across multiple websites, signing with Facebook, Google, things like that. We're all familiar. Multiple federated authorities. Federated helped bring the garden walls down, but it introduced more authorities. Identity federations basically created a digital oligarchy. This graph kind of demonstrates where we are. We spend a lot of time on some of these websites, and the power concentrates around them, despite it being federated. They're single hierarchical authorities, centralized or hierarchy of centralized control. Oh, sorry, this is actually, yeah, so these are some of the examples of people trying to bring identity back into the control of people, peers, OAuth, the OpenID Connect, FIDO. And ultimately, with the next phase that we're trying to enter into is something called self-sovereign identity, where basically every identity on the internet is an equal peer. There's no concentrated federation that acts as our identity provider. We are the identity providers in this model. Self-sovereign identity was coined by Christopher Allen. He's definitely spearheading decentralized identity. He's a very large proponent of this stuff. In a direct quote from him, he says that self-sovereign identity is an ideology to reclaim human dignity and authority in the digital world, and it's an emerging architecture of technology designed to enable that movement. So what's the ideology? I want to go through just the 10 principles he outlined in his manifesto on self-sovereign identity. Existence. Users must have an independent existence. This seems obvious, but they must have the right to be an independent person or entity online. Siloed and federated identities ultimately control that existence of identities on the web. Control. Users must have the right to control their identities. Users must control the privacy and control the ability to make the information they choose available. When we put trust in federated identities, they ultimately can decide what that is for us, and they ultimately do still have the control. And users have the right to access to own their data. Users should not be subjected to walled gardens and gatekeepers of data associated with their identity. Transparency. Users have a right to know and understand the systems, algorithms, the systems used, the administrator and operator network must be open, both in how they function and how they are managed and updated. The algorithms should be free, open source, well-known, independent of possible and particular architecture. Anyone should be able to audit and examine this stuff. It doesn't need to be siloed and closed. Users have the right to persist their identity. Just because some service goes offline and I've lost everything, I lost a bunch of MySpace music when they lost their music back in the day, and it's gone forever. I'm sure some of us have experienced similar things. Portability. Users have the right to identity portability. Information services about identity must be transportable. Interop is wanting to be here, and that's actually the next principle. Users have the right to interoperability. Identities should be widely used as possible. Identities should be able to cross borders, boundaries, networks, and systems and communities. And consent. Users have a right to consent. Users must be able to agree to the use of their identity. Any system that shares identities, claims, and associated data must require that consent from a user. And users have a right to the minimization around information associated with their identity. Users have the right to attest, assert claims about their identity without revealing personal information. Disclosure should really be minimized in all cases. Users have the right to identity protection. This one seems obvious, but it definitely should be mentioned. So the architecture. At the core of this was a spec that emerged called Decentralized Identifiers. It's a data model and syntax for decentralized identifiers on the web. Well, what is a DID? They're globally unique identifiers, resolvable from decentralized networks, cryptographically verifiable, abstractions over public key cryptography. Looks like a universal resource name, a URN, something like this, but they're just a little bit different. They define a fixed scheme, a DID method that is left for a specification to be defined, which ultimately defines how a URI is. DIDs use methods instead of namespaces, which are backed by specs that define the format of the identifier. The DID spec mentions the need for a blockchain or some type of distributed ledger. Depending on your use case, this might not be true. DIDs are the keys to resolve DID documents, decentralized identifier documents. DIDs and DID documents are the keys and values for a decentralized identity network. This is an example of what a DID resolving to DID documents. It's a JSON LD document, linked data. And you can kind of think of this as like a key, and this is the value in a database. And these are your public keys. And the document also specifies how these public keys can be used for authentication. You'll notice that there's a type here that's specified, an RSA verification key, postfixed with the year. the string can indicate to a reader how they should use this key, making the system and the algorithms here transparent. So I want to show this DID again. DIDs are keys to a document. They can be created, read, updated, deleted. So how is one created? Well, hypothetically, we can create one for DTN. Let's say all of us were issued a key pair when we all purchased our tickets here. In this example, this is a DID with the DTN method, and this is the public key of an ED 25519 key pair. And here's a hypothetical document for that identity, the public key that they were associated with, and how it can be authenticated. So how is a DID read? DID resolvers, they're kind of like DNS resolvers. You give them a DID and they resolve this document, or many documents. They're based on HTTP, so servers implement this identifier URI and return these documents to people. DID kind of serves as a great way to allow for interop between different systems like Scuttlebutt, IPFS, and DAT, and really anything else. Bring your network. DIDs open possibility to unify existing identity networks. Here's an example. Don't ever use this in production, but here's an example. Say I created an identity for my GitHub username. I chose to use a GitHub as the method and just my username as an identifier. And this is what my document might look like. We all have our public keys exposed. You can go to your username and add .keys as the extension, and you'll see each one listed. I wrote a small example resolver that goes out to GitHub and parses these keys and presents them in this format. If you would keep going down, you'll notice that there's an RSA signature, and I also have an ED 25519 key pair as well that it tells me it's there. So updating a DID is actually kind of hard. DID leaves this method up to the specification because updating stuff in decentralized networks, as we know, is not easy. You don't know how to resolve a conflict. You don't know when two values are, which one is the correct one in which order. You can use different techniques to figure that out, but ultimately DID doesn't want to define that for you. Deleting a DID is even harder, because most decentralized networks are immutable. Deletion, or actually revocation, is just as critical as an update, and also the spec leaves this up to the implementer as well. Sometimes revocation just might not be possible in the way you've designed your system, which is dangerous. And DID wants privacy by design, meaning pairwise pseudo-anonymous DIDs, off-network private data should not be able to be correlated to the DID, and data minimization and selective disclosure. This stuff kind of laid foundation for a new emerging spec by the W3C called Verifiable Credentials. DIDs serve as the base layer for an identity in a decentralized network. Verifiable credentials build on this layer to enable interop between networks. They are digitally signed electronic credentials, like age, where you're from, what right do you have to do something. DIDs can identify various parties who issue, hold, verify, or are the subject of such actions in a decentralized network. DIDs are the first step towards true self-sovereign identity. And just a quick recap of the self-sovereign identity principles. In existence, again, DIDs, you create them yourself. They are self-sovereign themselves. You have the right to exist independently of any system or governance. You have the right to control them. You own the keys themselves. You have the right to change and rotate them yourself as well. You have the right to access. You have the right to access your own data. If DID is following the privacy by design model, this should just come for free. And transparency. DID aims to define and use well-known public, open source, auditable, cryptographic algorithms that can allow authentication and can be understood by the mass. It's not a closed silo. It's not something the NSA is going to do. And persistence. Identities must be long-lived. Some systems use IPFS to store their documents. Some are actually storing some of this information on a blockchain and keeping it around forever. Identities have the right to persist forever. This isn't to be confused with personal information and the right to be forgotten, because DIDs by default are privacy by design, so this shouldn't actually be concerned. And portability. DIDs should be portable. I should be able to take my DID implementation and move over to IPFS, or take some of this information and move to Scuttlebutt and spread it around. And it should be interoperable. I should be able to have an identifier or identifiers that can point to my Scuttlebutt key, point to my key pair from my data archive. And consent. DIDs built with verifiable claims allows this model to truly exist. There's some interesting stuff happening with the Uport guys that they're really trying to push this model forward. And minimization, handing over, an example of this might be like you going into a bar and showing your driver's license to show your age. You've given your ID to the bouncer and he's trying to just assert who you are and your age. But you've given him quite a bit of personal information. There should be a way to minimize this without this person actually knowing more than they need to be. And protection. This is, again, the heart of all of it. Users have the right to be protected, and privacy by design should make this possible. So who's putting DIDs to use today? There's actually a lot. There's a whole foundation dedicated to this. The Decentralized Identity Foundation is there's more than this now, but this is the latest screenshot I got. These are all the groups involved in trying to push this stuff forward. And if done correctly, they're all implementing their own DID methods, and they all should be interoperable with each other. I should be able to use my identity scheme with Microsoft and my identity with Uport and collectively bring them together. Here's a very short list of some of the active provisionals and specifications around the DIDs that are in play. The registry online has a much more exhaustive list. This is a little outdated because I believe Uport is now deprecated. So some ideas. Authentication for decentralized applications. So there's new spec that is finally making its way to the browsers. Web authentication. Web authentication kind of defines your interaction between a relaying party and an identity party and brings servers really at the forefront. And you don't really need to have that. And we've done some examples of using WebAuthn YubiKeys with DAT, and it actually proves useful. You can come to the Beacon browser, you come to Chrome, and bring two-factor authentication to a decentralized application without going to some intermediate. You don't need Okta. And DID resolvers for uniformity. This would be great. Query keybase with my ID, get a document back, maintain a bunch of different identities in a uniform way. And it allows this way to be interoperable between different applications. If we all understand the same way in spec for addressing public keys and identifiers, we might make a more secure web. So, call to action, we can do better. We can use some of these ideas and principles. Maybe it's not decentralized identifiers, but maybe this is just the first start. But these 10 principles of self-sovereign identity led to the creation of this spec. And I believe that we can do better in using these ideas. A few resources for the curious. Self-Sovereign Identity Manifesto by Christopher Allen. You can check out this link. He outlines his principles, the phases of identity, and why he thinks this stuff's important, and ultimately which led to the DID spec being worked on by the W3C community group. This is an active registry. This is being updated very often. And for those who just want a quick digest or a primer, there's a website as well by the W3C. This is a short talk. I appreciate your time. If you guys want to talk about DIDs, decentralized identity, and how we can try to build a more uniform, ubiquitous web around authentication, come chat with me. That's it.